I want to walk through some basic things that you can look for when you are reviewing pull requests and code. So I'm just going to list them down and then we will explain them. Null checks, using statements, exception handling, log statements, retry policies, excessive enumerations, repeatable logic, and tests. So that's my list. So I want to break down each of these and explain what specific things you should be looking for in each of these elements. So the first one is null checks. Null checks is basically, for example, if we have a list of objects and then we have logic that acts on that list of objects, whether it's filtering, selecting, checking if the list contains something. Our assumption with that is that the list is not null. But, as we know with computers and software, we have to begin to expect the unexpected. So our assumption is that at some point that list, due to improper state or bad state, can potentially be null. So we want to make sure that we have null checks in place where possible. So a prime example of this would be if we have in .NET, if we have some kind of list of elements, and then we do a select, and then we do maybe a .where. We want to make sure that on that query we're using the null check operator of the question mark. And this could also be in the context of if we get some return value back from a method, before we act on that, we can check that the return type is not null. And, that's just two very, very general examples. But in your code, in the method that you're reviewing for your pull request, you want to make sure that whatever is being acted on, whatever variable is being manipulated or used, cannot be null. So if it's appropriate to have a null check in place, then there should be, and that's just something that you can begin to look for and begin to get in the habit of checking for, is null checks. So the next one deals with using statements. And it's not specifically just using statements, but using statements encapsulates a lot of the principles within it. So what I really mean to get at with this is proper disposal of resources. So in the context of .NET, if you ever work with stream writer, memory stream, anything really I/O bound, like any specific I/O bound operations, whether you're dealing with a uploaded file, you're parsing a CSV, all that stuff that deals with that, it has a tendency to hang on to those resources beyond the scope of the calling and executed code. So you want to make sure that all that logic, especially if you're using a stream writer or memory stream, is wrapped or contained in a using statement. A using statement, upon completion of execution, is going to automatically release or dispose of those resources for garbage collection. So garbage collection is going to come in and check that there's no active references to those variables, meaning that there's no active pointers, and then dispose or free up that memory. So we want to make sure that we are disposing of resources correctly. And this can go beyond just using statements. If we have any global variables that are being set, let's say outside of the executed code or the calling code or method, whatever it is, if that's being assigned data, or let's say it's being assigned a large list of elements that's 500 megabytes, even a gigabyte of data or memory, we want to make sure that that's set back to null upon completion of whatever code it is. So if we have a global variable, we want to make sure that that's being reassigned back to null if it's appropriate, and we want to make sure that we're using statements where we should be. You want to limit your manual usage of the iDisposable implementation in .NET as much as you can, because it's easy to get wrong, and there's a lot within the framework that already handles that stuff for you, using statements being one of them. So just check for those and check that using statements are used appropriately and that global variables and other variables are being basically reassigned back to null or basically being deallocated. The next one is going to be around exception handling. So similar to nulls, you want to always have in your mind worst case scenario when you're dealing with code, because they're computers. Computers can get into bad states, which leads to the fix all problem of turn it off, turn it back on again, because it resets the state of the computer. And so exception handling is no different. We need to be thinking of, for example, if this API call fails, is that going to be handled appropriately, or is it going to lead to an unhandled exception that the end user is going to see, and they're going to see an error on their screen. They're going to have to go back and refresh and do all that. And so we want to make sure that if it's appropriate to have code wrapped in a try catch or a try catch finally to handle that accordingly. And there's other ways to do this. You can set up, on your HTTP client in the middleware to automatically handle exceptions, especially if they're global exceptions. You can create retry policies that we'll get into a little bit, but we want to make sure that potential exception is being handled and also being logged appropriately, whether it's logged as a critical or an error information, whatever log threshold you want to throw it at. But we want to make sure that exception is handled, and if it's appropriate, the state of the system can continue beyond that exception. So we want to have not only the exception being caught and being handled appropriately, but also we have logic in place to say, okay, if this does happen, then we have to do this, whatever that is. We have to return back to somewhere. We have to return back this error code or status code back to the user. We have to do something to accommodate the fact that this errored. If we don't have any of that combination logic, then it can lead to unexpected results, right? If we've always been to a site or anything that all of a sudden we get back this server error and we don't know what to do. And that's the last thing that you want to have happen in your system. The next one is going to be log statements. Logs are so vital to any system. It's one thing when you're writing it, everything makes sense. All the logic, all the decisions you remember, all the assumptions you remember. But the reality is that you're not going to remember that in a year or 2 years, especially not a few years down the road. And so log statements not only clue us into what's happening into the system, but they also can make us aware of certain assumptions that we've made, and also just clue us into the state of the system as it's progressing. And so log statements are so vital, and we need to make sure that we're not just logging for the sake of logging, but we need to make sure that we're logging in plain English, plain text, whatever language you use, but just make it simple to understand, right? Make it simple to read and make it easy on yourself. Logs are for us. We need to be writing logs that make sense to us. We don't need to be writing these cryptic, just obscure logs that are meaningless, right? We need to write clear and succinct logs that actually tell us useful information. And it's logging is hard to get right, but it's one of the things that we need to get right, because when something happens, when something goes wrong, the logs are your first way of trying to diagnose what's going on. So if you don't have good logs in your system, it's going to make it that much harder on yourself. So logging is something that needs to be in place, and it should be something that you're always looking for, especially in a pull request, especially when new code is being added or existing functionality is changing. Check to see if it makes sense to add a log statement, especially if any kind of state of the system is changing. And so always check for logs. And if a log doesn't make sense or isn't clear, don't be afraid to push back on updating what a log statement says to make it a little bit more clear. The next one is retry policies. Retry policies we've talked about in the context of queues, but retry policies also make sense in the context of whenever you're dealing with API calls made on the HTTP client. You can use libraries or frameworks to automatically retry a call if it does fail. You can set it for increasing on a specific interval. You can create like some kind of exponential increase for delaying the retry. But retry policies, if it makes sense in your system, should be something that you have in the back of your mind that you potentially may be thinking about, especially if it's dealing with any kind of like sensitive data. It's one thing to make an API call and have it fail and then handle the exception. But if there's ever a possibility that there's an outage, or maybe you're just dealing with an API that's not exactly the most, it doesn't have the best uptime, then you may want to consider adding a retry policy to try it again in the event that there's some obscure outage or error or whatever it is. So just have that in mind. It's not necessarily something that you should always implement, and it's certainly not something that you should hold up a PR for, but it's something that you should be thinking about. And I think it's going to lead to questions being asked about your system that are important, and I think that's going to help your team out. The next one is going to be, oh, well, before we get into the next one, I should say that retry policies can be handled a number of ways. They can be handled through middleware, through custom extension code on HTTP client. The middleware is probably going to be the most appropriate. There's a number of different libraries and that are out there. You can in NuGet packages that will do this for you. But in the context of queues that we've talked about in retry policies, that's also set up in middleware. So if you're ever doing kind of like any more event-driven design, retry policies are something that you for sure are going to want to have included in your system. We've talked about that in previous videos. We've talked about that in my system design series if you're curious. So you can go back and look at those videos if you want to see the code to make that happen and to see the effects of not having it versus the effects of having it in your code. So moving on to the next one is going to be excessive enumerations. And this one is really .NET specific because if you're ever dealing with a collection and it's of type IEnumerable, which is really the base implementation of like list and all these things. So you have iCollection, IEnumerable, and if you ever have IEnumerable and you're filtering, you're doing dot wheres, and then you have logic, and then you have another dot where, you want to make sure that you're not repeatedly calling to-list if it's excessive. Meaning if you ever have if statements that check to see like, okay, if your list contains the color blue, then, maybe like do a dot where, select the elements that are blue. But then if you have another one right below that and you have, okay, if the elements that are blue, if they haven't, if there's more than 50, then filter it again. So if we're having repeated dot wheres based on different conditions, it doesn't make sense to call to-list on each of those because you're enumerating over the entire collection again, therefore loading it all into memory. So you have not only duplicate allocation of memory, which will lead to resource constraints on your system, but it's just unnecessary and it'll slow down your system. So you want to make sure that when it's appropriate to limit the enumeration of your collection. So you don't want to call to-list 3 times if it only needs to be called at the very end before you return that type. Because what happens in IEnumerables, if you call dot where and then you call another dot where, they'll basically stack on top of each other, meaning they'll add to that delayed query. IEnumerables are, you can think about it in the context of delayed execution. So whenever you call to-list, you are then performing or executing that query with all those conditions included. So you don't want to do that multiple times. You can look up IEnumerables, and this is more of a common problem that you'll see pop up in .NET is enumerating a collection too many times, more than is necessary. And so it doesn't hurt the code to enumerate it more, but it hurts it in terms of performance and allocation of memory. The next one is going to be repeatable logic. So if you ever look at code and you see a block of code that is duplicated and could be abstracted out into its own method, whether private or public, you should probably call that out to say that, okay, if we have something that's identical, we could probably bring that out into its own method and then call it from both spots. That way you don't have to go back and update both areas in the code for every change. It just helps keep things concise, and it also makes testing a little bit easier, which is the next and final thing that we're going to get into is tests. Nobody likes writing unit tests. They're just something that we have to do, whether it's unit tests, integration tests, regression tests, whatever test it is. In this context, we're going to be talking about unit tests, but unit tests, again, if you see a method that can be or should be unit tested, just write a test. Just make sure it's behind some kind of test to make sure that, okay, if this logic changes in the future, we should get a failing test that then we have to go back and update. And if existing functionality has changed and a test fails because of that, that should warrant a second opinion or a second look at, does this code change make sense, and is it going to cause a problem in our system? That's what unit tests are for, right? To safeguard against breaking changes. And so if you see an area in code that, in the pull request, that somebody made a code change to existing code and then had to go back and update the unit test, that should to you tell you that you need to be a little bit more particular when you're looking at this pull request, because you want to make sure that the updated unit test is actually there for the right reasons and not just to accommodate just the test failing. So you just want to make sure that the code makes sense and is correct. So if you see an updated test, just take a look at that code and read it a little bit more in depth and make sure you understand. And at all times, if you don't understand something about a pull request, always reach out. Always talk to whoever the PR, whoever made the PR for. Just talk to them and honestly just see if you can schedule time or just meet up with them and say, hey, like, can we walk through this? And just ask them, just to walk you through the logic in the code. You should always feel free to ask whatever question you need to. You should always have the freedom to meet up with whoever made the code and for them to walk you through the changes, because it's important that everybody's on the same page for the pull requests, because everybody's working in the code base. Everybody at some point is probably going to have to touch code that you wrote or changed. So it's important just to take that extra bit of time to make sure that everybody's up to speed and everybody's aware what these changes mean. And if you need documentation, if you need better log statements, if you need any kind of clarification, just ask. Just it's better to ask than not ask and be confused. You don't want to be confused, because the odds are you probably will have to work in the same code spot at some point. So it's better to understand now than understand later. So hopefully this was helpful. Again, this is just a starting point that you can take for when you're looking at pull requests. But yeah, thank you all for watching. I'll see you in the next one.